Inverse trigonometric functions. Let's just first remember, what does it mean to be an inverse and also be an inverse function? So let's start back with what you learned during freshman year. If I provide you with an equation such as f of x or y equals 2x plus 3, the first thing I'm going to do is I want to visualize this. So I'm going to start on the y-axis at positive 3, and I'm going to use the slope to go up 2 and over 1, up 2 and over 1. Now let's go ahead, and I think we'll have a better idea of what this looks like if we can actually provide values that match with this. So when I plug in 0, 2 times 0, 0, plus 3 is 3. When my input is 1, 2 times 1 is 2, plus 3 is 5. And let's do one more. 2 times 2 is 4, plus 3 is 7. If I conducted a vertical line test, you can see that every time I create a vertical line, it would cross this blue line at most one time. What does that mean? It means that every x has at most one y that it matches up with. That's the definition of being a function. An x value or an input value cannot match up with multiple output values that are different values. Now, how do we actually create something that would be the inverse of this? Not only the inverse, but how do we make sure that it's an inverse function? Let's visualize this. 0 in this case for this function maps onto 3, 1 maps onto 5, and 2 maps onto 7. I want to create a function that does directly the opposite. It pushes 3 back onto 0, 5 back onto 1, and 7 back onto 2. So algebraically, I'm going to take this original equation, and I'm going to switch the x and the y, and now I'm going to isolate for y. So I'm going to subtract 3 to the opposite side and divide by 2, and now I can say the inverse is x subtract 3 divided by 2. Now I knew visually that this inverse equation is also going to be a function. So it's going to be an inverse function because mentally I conducted not a vertical line test, I conducted a horizontal line test. A horizontal line test that works the same way a vertical line test does checks to see if the inverse equation is a function. And we can see the inverse is in fact going to be a function, which means every input value for this equation maps onto at most one output value. Let's check this. If I plug in 3, so 3 is my input, 3 minus 3 is 0, 0 divided by 2 is 0. Let's try 5. 5 minus 3 is 2, 2 divided by 2 is 1, and lastly 7. 7 minus 3 is 4, 4 divided by 2 is 2. Notice how the input and the output values just swapped places. We could make a few statements here. We could say, let's choose any one of these values. We could say, when the input value is 1, the output value is 5 for the function f. For the inverse, when the input value is 5, the output value is 1. Let's try another one. When the input value of the function is 2, the output value is 7. But for the inverse function, when the input is 7, the output value is 2. 2 inverse functions. Again, not just inverse, but inverse functions. If it's an inverse function, that means when I substitute an input value into the inverse, it can come up with at most one output value. Let's start off pretty simple. Let's say that f of x equals the sine of x. And I know that most students prefer to work with degrees, although hopefully you recognize at this point that generally we're going to work with radian measurements. So if I share this with you, that means I'm looking to see at 30 degrees what is the sine value. So f of 30, and I'm going to come up to 30 degrees, sine is the second number, is equal to 1/2. True statement, right? But what if I reverse that? So instead, let's say I want to reverse the statement. So right now with the function, this is the original function, here's my input value, and here's my output value. When I substitute in 30 degrees, I get an output value of 1/2. Now, for the inverse of this, I'm going to make another table, input and output. For the inverse, it still needs to be true to be an inverse function that when I plug in 1/2, there can be at most one value that matches this. So let's look at our unit circle and let's find out where can I find a value of 1/2 for sine functions. So I'm going to plug in 1/2, and my mind says it should be 30 degrees. Let's check. So right here is positive 1/2, so we could write down 30 degrees. Maybe other people would write down pi over 6, all true statements. But it's possible somebody else says, Miss Bradley, I think there's another answer. I also see a positive 1/2 as a sine value at 150 degrees, also known as 5 pi over 6. And that's when we get into trouble. So I could write down 30 degrees, or I also may write down 150 degrees. And now we see we have an input value that matches up with more than one output value, making this inverse not a function. So mathematicians decided to restrict the input. They restricted what we could plug in order to ensure that we could only get one output value. I'm going to show you graphically how that works. The sine of x. Again, this is for you to have a deeper understanding, and then I'm going to teach you the shortcut. But please take notes. So if I'm in a graph, f of x equals the sine of x, the first thing I want to know is what is the length of one cycle? So what is the period length? I'm going to take 2 pi and divide it by whatever the b value is, happens to be 1. That means one cycle is a length of 2 pi. I know that any trigonometric function has 4 steps. So I'm going to take it, divide it by 4, and that tells me that each one of these steps is a distance of pi over 2. And now let's start plugging this in. So I plug in 0, the sine of 0. If you want to use this unit circle to help you have a better understanding, here we go. The sine of 0 is 0. Then let's go to pi over 2. The sine is 1. At pi, the sine is 0. At 3 pi over 2, the sine is negative 1. And at 2 pi, after one cycle, we're back up to 0. But hopefully you remember, it doesn't just stop here. This is just one cycle. And it makes this wave curve that goes to the left and it goes to the right, and it just keeps going. So let's practice what we did with the first example, which was linear. Remember, f of x equals 2x plus 3? Well, let's do the same thing. If I made vertical lines, so I'm doing the vertical line test, we can see that this is in fact a function. Every x matches up with at most one y. The problem is, if I go to test the inverse, notice that when I would make a horizontal line test, notice that it would cross the black line well over one time. And any time it crosses more than once, it means the inverse is no longer a function. So mathematicians decided, you know what? We're going to restrict what we can plug in. And if we restrict what we plug in, we're guaranteed to then turn the inverse into a function. So mathematicians said we are only going to plug in input values that are in between negative pi over 2 and positive pi over 2. So here's the shortcut. Please make yourself a circle. I know positive pi over 2 is up here at 90 degrees, so up 90, and then I'm going to drop down 90 to negative pi over 2. And I want you to shade in. You can use your pencil or pen, highlighter, whatever you need to do. Mathematicians said, hey, if you only choose input values that go up 90 degrees or drop down 90 degrees, you're going to be guaranteed to only have one output value, making this function, this inverse, a function. I should have said making this inverse equation a function. So let's go back up here. If I try this now, and let's check this out. If I want to know where can I find a sine value that has an output of 1/2, that's what this means. Let's check. But now I'm only able to check in these two quadrants, quadrant 1 and quadrant 4. So I'm going to analyze the sine value just right here. That's the only place where I have a positive 1/2. And that's why I'm able to choose an answer of only 30 degrees, which could also be represented as pi over 6. Let me write a few more down for you. We've established for this particular problem we're working on that f of x is equal to the sine of x. We're able to use our unit circle and look only in quadrants 1 and 4 and locate where do we find a sine value of negative radical 3 over 2. It's going to be right down here, the sine value being the second one. So I'm going to represent this. Notice how I'm dropping down. Now, how much am I dropping down? I'm dropping down 60 degrees. So I could write it as negative 60 degrees, or it may be represented as negative pi over 3. Let's find where is the sign equivalent to negative radical 2 over 2. It's going to be right here. Okay, so I'm dropping down. We don't want to say all the way around. We are dropping down or we are going up. I'm dropping down a distance of negative 45 degrees, and that also can be represented as negative pi over 4. Let's do the next one. Where can I find radical 2 over 2? It's right up here. It can be written as positive 45 degrees, positive pi over 4. So if we do not make the statement in our homework that says f of x equals the sine of x, we're able to know what is the inverse of this function by this first statement. But if that is not made, I want you to recognize this means the exact same thing. It's telling us, hey, we're looking at the inverse of sine. That's what this statement is. Look at the inverse of sine. So I'm only going to focus in on the first quadrant and the fourth quadrant, and I'm locating where do I find negative radical 3 over 2, and that's going to be right down here. Again, I'm dropping down 60 degrees, so negative 60 degrees, also known as negative 1 pi over 3. Same concept. Inverse sine is the same as arc sine, so I'm dropping down 45 degrees, or negative pi over 4. And lastly, same thing as our previous example, arc sine is the inverse of sine, and so here I'm going to bump up 45 degrees, which is equals the cosine of x, and recall that arc cosine is the same as the inverse of g of x in this situation. Okay, so if we're asked to look at the unit circle, and let's identify where we can find a cosine value of negative 1/2. Cosine being the first value is negative 1/2. Okay, right here we see one at 120 degrees, also known as 2 pi over 3. And I also have one down here, so I have two places. Now, why is that a problem? Because if this inverse equation is a function, it cannot have two separate output values. And so just like we restricted the input for cosine, we're going to do the same for sine. We're going to do the same thing for cosine. Let me first just graph the cosine function. At 0, what is the cosine of 0? The cosine of 0 is 1. At pi over 2, the cosine is 0. At pi, the cosine is negative 1. At 3 pi over 2, the cosine is 0. And one cycle here we complete at 2 pi, the cosine is positive 1. And we know that this is cyclic, making this wave curve over and over again. So is this a function? Yes, the vertical line test shows that this is a function. But the inverse equation would not be a function because it does not pass the horizontal line test. So they just decided to restrict the input values for the inverse function for cosine, so arc cosine, and they're going to restrict those between 0 to pi. So please make yourself a circle. And for arc cosine, also known as the inverse of the cosine, we're going to go ahead and we are going to shade quadrants 1 and 2. And now we'll be able to determine only one output value. So let's locate again. We were at 120 and we were also at 240 for the statement, but only 120 lands into quadrant 1 and 2. This is the correct statement. And as I explained, for restrictions on sine and cosine, the same thing occurs for tangent to ensure that our inverse is in fact a function. So let's use our unit circle now to evaluate each one of these mathematical statements. Let's find where is the sine equal to positive 1/2. It's here both at 30 degrees and also at 150, but it has to occur for arc sine in quadrant 1 or quadrant 4, making this answer either 30 degrees or pi over 6. And most often they're going to tell you to answer within radians or within degrees. Okay, arc cosine, where's the cosine equivalent to negative radical 3 over 2? Arc cosine, let's find negative radical 3 over 2. It occurs right here at 210 and also at 150. But arc cosine can only be in quadrants 1 and 2, making our answer 150 degrees, also known as 5 pi over 6. Where is the sign equivalent to positive 1? It's equivalent just right up here at pi over 2, at pi over 2. Notice that again, we're going to go for arc sine, from pi over 2 all the way down to negative pi over 2. So this answer is going to be pi over 2, also known as 90 degrees. Where can I find a cosine of negative 1/2? Cosine being the first value. Yeah, I should have had this up here so you could have seen this. My fault. Cosine being the first value, it could be at 120 or also at 240, but it has to be in quadrants 1 and 2, making it 120, which is 2 pi over 3. Evaluate what the tangent is at several of these locations. So where am I actually going to do this? I am going to do this for the purpose of being able to evaluate arctangents. So I'm looking right now just in quadrant 1 and also in quadrant 6. I'm going to start by finding what is the tangent here. And I'm going to put a little box around this so it stands out to me. So in each one of these boxes, I'm going to write down what the tangent value is. So sine divided by cosine. So I'm going to take 1/2 and divide it by radical 3 over 2. I recognize division turns to multiplying, and I'm going to flip the second fraction. 2's are going to be simplified to 1. I get 1 radical 3, but written in proper form would be 1 radical 3 over 3. Maybe I can do that a little bit neater. 1 radical 3 over 3. Okay, this is a really easy one to do. When you take sine and divide it by the cosine, they're the same value, same sign. We end up with just positive 1. Now notice that these values are very similar. The only difference between going up 30 degrees or dropping down 30 degrees is that the sign is negative. So they're different values. I'm able to take and copy this value down here, but it just needs to have a negative sign with it, because when you divide values that have different signs, your final answer is going to be negative. Let's go up to 60 degrees, and again, I'm going to identify what the tangent is. Radical 3 over 2 divided by 1/2. I keep the first fraction, turn division to multiplying, and flip it, and we get the square root of 3. So positive square root of 3 there, negative square root of 3 down here, positive 1 up top, negative 1. Now what is the tangent here? Sine divided by cosine. Well, 1 divided by 0 would be undefined. And down here we also get an undefined value, an undefined value. Can I use these values over here? Can I use these values over here and be able to justify these answers? If you didn't understand how I got this, go ahead and take sine divided by cosine. You're going to get this exact same value. Again, I'm taking and dividing the same numbers. These 3 locations all have positive, resulting in a positive outcome. Down here, when I'm dividing, the only difference is that one is negative, one is positive, and that's why we get a final answer or value that is negative. Okay, let's do 2 more examples here. Let's find the arctangent of negative radical 3 over 2. And so I'm going to take that unit circle, which I got the shortcut. It has to occur in quadrants 1 or 2, making my final answer 300 degrees, which is also equivalent to 5 pi over 3. Where is the tangent equal to negative 1? So arctangent of negative 1. Negative 1 occurs at, and I got to go back, I see a mistake I just made. It occurs at 7 pi over 4. It also occurs at 3 pi over 4. Now what mistake did I make? Instead of writing 300 degrees or 5 pi over 3 on the last one, what it wants me to do is it wants me to drop it down. So instead of doing this, it drops down 60 degrees. It drops down pi over 3. We don't want to think about going all the way around here. We're dropping down to 300. So I have to drop down 60, drop down pi over 3. Those 2 are equivalent. Same concept here. Yes, the tangent is negative 1 at this location and also at this location. But when I look at the shortcut circle, I can see that arctangent only occurs in quadrants 1 and 4. So how do I get here? I'm dropping down 45 degrees. Dropping down 45 degrees, which is equivalent to negative pi over 4.